Hi everyone, this is the Unit N exam review for Geometry A. I'm going to take this and blow this up so I have a little more room to sketch for these first couple of questions. Okay, the first one says, in a circle with radius 210, find the length of a chord of a 150 degree arc. So let's make sure we sort out what this question's asking. We've got a circle, not bad for being on the iPad. The radius is 210. So that means both of those lines I just drew have a length of 210. Okay? And it's a 150 degree arc, which means this arc here is 150. And I want the length of the chord, meaning I want this. Okay, that red line is what I'm trying to find. Well, remember that this angle that I drew here, this is a central angle, and central angles are just equal to their arcs. So really, if this arc is 150, then this arc here in the middle is 150 degrees. Okay, and I'm not sure how all of the other teachers have taught this. I've taught my students to do this with the law of cosines. So I would picture this triangle kind of not even inside the circle. I would just do this. I would say, okay, we know this is 210. We know this is 210. We know this angle is 150. This is the side length I'm trying to find, so we would label that side A, which makes the angle across from it angle A. And then my two side lengths are B and C. Law of cosines, remember, looks like this. A squared equals B squared plus C squared minus 2 times B times C times cosine of angle A. And really, I'm just going to take these two things and plug them in for B and C, and this and plug it in for angle A. So it's going to say A squared equals 210 squared plus 210 squared minus 2 times 210, excuse my messy handwriting, doing the best I can, but I also want to write fast, and then times the cosine of 150. And this is one of the nice ones where you've got this entire side of the equation all filled in already. So this whole thing can type into your calculator all in one shot. Let me take just a quick second and do that. Okay, when I type all of this in, I get 164,583.4. And then remember, that's really equal to A squared. So then from there, I would need to take a square root of both sides. So if I take the square root of that, I end up with A, which is the side length I want, about equal to 405.7. Okay, which does seem kind of large, but when you really think about it, these two side lengths are both 210. So if they were laying like straight out next to each other, like here and here, well, let's do this. If it was like 210 and then 210, that'd be a total length of 420. An angle of 100, and that would be an angle of 180 if they were laying out straight next to each other. Angle of 150 is not that far off from that. Okay, so really my picture is not drawn super accurately because a 150 degree angle would be almost flat. So I think this 405 is a reasonable answer. Oh, and that would be in millimeters. Okay, same process is going to work for number 2 and number 3. So in a circle with radius 55, find the chord length of a 60 degree arc. This would be, draw my central angle in here. The radius is 55, so both of these side lengths are 55. My arc is 60 degrees, so I'm just going to jump right to saying this is 60 degrees here. And I'm trying to find this side length here. I'm just going to plug that right into law of cosines. So I would say a squared equals 55 squared plus 55 squared minus 2 times 55 times 55. You can probably type it in your calculator faster than I'm even saying it. And then times the cosine of 60. Give me a second to type away on that. The dinky little calculator I'm using came out to 3,024.9999999. I'm going to go ahead and say that's supposed to be 3,025. So I would say a squared equals 3025. And then don't forget that's not your final answer. You do need to take the square root of that. And I get, again, I got 54.9 repeating. I think that's probably just supposed to be 55. Oh, and actually that makes perfect sense. Didn't even catch that before. But if you look at this, if this is a 60-degree angle, and these two sides are the same, that means these two angles are going to have to match. Okay? So you've got 180 degrees in your triangle total. If this is 60, that leaves 120 degrees for these two. Split that in half because those two angles have to match, and these are both going to be 60s as well. So this is really an equilateral triangle, 60, 60, 60, which means all three of your side lengths are going to be exactly the same. Okay, so if you caught that ahead of time and you just knew that and could write it down, awesome. If you didn't know that, though, this is the process you would go through. Obviously, I didn't catch that. So, all right, now let's look at number 3. Number 3 is exactly the same as number 2. The only difference is instead of a 60-degree arc, you've got a 144-degree arc. I'm going to try to get fancy here. Nope, that's not going to work. Okay, I'll just write it out again. I'm not going to draw the picture again, though. Hopefully you're okay with that. I'm going to write the exact same thing I did in number 2. Just change the angle at the end. So 55 squared plus 55 squared minus 2 times 55 times 55 times cosine 144. Let's type away on that. I end up with a squared equals 10,944.55. Take a square root and a square root, and I get about 104.6 for my final answer, which again seems reasonable. 144 is going to be pretty close to being flat. The two radii are both 55, so two of those together would be 110. If this is close to being flat, it's going to be just a little less than that 110. So 104.6, totally reasonable. Okay, let's move on to some more fun here. The next question says, find the measure of arc CB. And I love these circle questions because there's so many different ways to come to the right answer. But what I see right away is that arc CB, which is here, is intercepted by this angle here. Okay, sort of that ice cream cone thing where you look at the ends of the arc. And that is an inscribed angle because that angle goes all the way across and the vertex is actually on the circle. So when you have an inscribed angle, the angle is 1/2 the measure of the arc. So if this is 53, arc CB would be double that. Okay, so CB is going to be 2 times the inscribed angle, which is 53, which is 106 degrees. Simple as that. Okay, now we want the measure of arc ABC. That would be this. Let's highlight that. Arc ABC is here. I would love to assume that that's half the circle, but I can't assume that. And here's why I know I can't assume that. We learned a theorem that said that if an angle is inscribed in a semicircle, which this looks like it might be, if an angle is inscribed in a semicircle, it has to be a right angle. But look at this. This is 89 degrees, not 90. So it's awfully close, but it's not half the circle. It's not going to be 180 degrees, so don't get too quick to guess that. Let's see, how would I go about this one? I would probably go with what we just figured out. So up above we figured out that arc BC is 106, and I can stick with that because my all my measurements are the same. It's still 53 and 89, just like it was up above. Okay, and then I would use the fact that this is a triangle, and a triangle has to have 180 degrees, and I would subtract these two from 180 to get this third angle. So let's see, that's going to be, let me switch my pen here. That would be 38 degrees in here. And then I would say, just like we did on that last question, that if this angle is 38 degrees, that this arc AB would have to be double that. So 38 times 2 would leave me with a 76 degree angle out here. And then if I wanted the total, I would add these two together. Okay, so 76 plus 106 is going to give me 182 degrees. So not quite half the circle. Make sure you don't make assumptions about that. Make sure you don't make assumptions that that line goes straight through the center. Sure looks like it does, and it's awfully close, but it's not actually the center. Okay, what else we got here? AB is the diameter. I'm just kind of reading through here. AB is the diameter. We know AB is perpendicular to CD. Let's mark that. And line L is tangent to circle O at point A. Justify why DE is equal to EC. Well, actually, for that, the fact that this is tangent really doesn't have anything to do with that. What we have here is we have a line going through the center of the circle, and it's perpendicular to this chord. If you have a line going through the center and it's perpendicular to the chord, we learn something called the, I have to think of the name of the theorem. The chord center theorem, which again, I would not stress about knowing the actual name of the theorem as long as you know what the theorem says. The chord center theorem had like 4 parts to it, but the first part of that theorem said that if a line contains the center of the circle, which this does because we know it's a diameter, it goes right through the center, and it's perpendicular to a chord, that it also bisects that chord. And remember, bisects means it cuts it into 2 congruent pieces. So that's how I would justify that DE is congruent to EC. I guess so I would say by the chord center theorem, AB bisects DC, and then I would say by definition of bisect, DE would equal EC. Okay. That's it for Unit N. That was a pretty tiny unit for you. I would make sure you kind of go back and look over your notes, maybe over your test review and things like that for that unit, because there may be some other things about circles that you're going to need to know for your exam. Okay? Good luck and happy studying.